So in this video, we're going to talk about quadratic equations and how to solve them by factoring. So before we get to the nitty-gritty of solving these types of equations, let's take a closer look at how they actually appear and some of the fundamental information we're going to need in order to solve them. So first off, the standard form of a quadratic equation is anything that kind of looks like this beast, which is ax squared plus bx plus c equals 0, as long as a, b, c are constant numbers, so they're standing in for actual number values with a not equal to 0. We'll go into what this a not equal to 0 business is tomorrow in class. But for now, let's look at a couple of examples of quadratic equations. So here are 3 examples. Notice that the first one is already written in this standard form, as is the second, where c, there's no constant term in this example, so that's really just a value of c equals 0. We could rethink of it as the value 5x squared minus 3x plus 0 equals 0. So the value of c is really just 0. So it's still a quadratic equation in standard form. The third one, however, though it is a quadratic equation, it's not written in its standard form. Now, how I know it's a quadratic equation, or what distinguishes a quadratic equation from the equation of a line or a linear equation, is this x squared term. This x squared term is what makes the equation quadratic. Notice that there is an x squared, a value of x squared present in all 3 of those equations. So this is definitely quadratic, and we could re-represent it in standard form by bringing these values on the right-hand side over to the left, by basically subtracting 12 from both sides and adding x to both sides. When I do that, I'll end up with x squared plus x minus 12 is equal to, well, by bringing them over, they've canceled out, giving me 0. So this is the standard form of this quadratic equation. Now, we put it in standard form for a lot of reasons, but one of the main reasons is to directly compare 2 equations to see if they're actually the same as each other. That's why it's a standard form or standardized form. Now, if you haven't already tried these 2 questions on your sheet, pause this video and try them now, as we're going to need to know how to solve these types of equations in order to also solve quadratics. So now that you've done that, the way you've most likely solved them is the way we've done most linear equations, by isolating the value you're looking for. So to do that, I'll add 10 to both sides. I end up with 2x is equal to 10, and then I'll divide both sides by 2 to get x is equal to 5. Pretty simple. And in number 2, you likely divided both sides by 12 to get x is equal to 0. That's 100% valid. But I'm going to point out another way that you could have thought of these 2 equations, particularly number 2 at first. So I'm going to erase the work I've done here. Notice that 12x is equal to 0, which means that the 2 factors of this number 0 are 12 and x. Now 0 is very, very special, because unlike other numbers like 16, which can be represented in multiple ways as a product of 16 and 1, or 8 and 2, or 4 and 4, in order to arrive at 0, you must multiply by a value of 0. The only value which will multiply to 0 is 0. So I know that x must be 0, because 0 is the only number which will multiply to itself. Now that's very, very powerful, and in fact it gets a fancy mathematical name called the zero product property. And formally it says that if you have the product of 2 values, aka 2 factors of 0, that only happens when one of those 2 factors is 0. The only way you'll result in 0 when you have multiplied 2 values is if one of those 2 values is 0. This is going to be essential to helping us solve quadratic equations. And so kind of a basic idea that's very, very powerful mathematically. Now, you can actually always use that property. When you have 2 values equal to 0, it must be the case that one of the factors of that number is 0. So if I go back and look at number 1 and I factor it by pulling out the greatest common factor of 2, I'll be left with x minus 5. Well, that means that either one of these two factors must be 0. And since 2 doesn't equal 0, it must be the case that x minus 5 is equal to 0. Its other factor. Therefore, x will have to be 5. So those are two ways of solving linear equations. This second method, using the zero product property, is actually going to help us very much when we get to quadratic equations. So let's actually look at a couple of quadratic equations and see how we can solve them. So first, we'll look at this one, which is already in standard form. Now, this is another reason why standard form is very helpful. I have a number, which is x squared minus 5x minus 14, which is equal to 0. Well, the zero product property tells me that one of the two factors of this number must be 0. So I'm going to re-express the left-hand side of this equation in factored form and use the zero product property. So the left-hand side will factor to x minus 7 times x plus 2, and that will all be equal to 0. Again, to factor, if you forget how to factor, you can go back and review the factoring video. But now that we have it factored, we're going to use this zero product property. Now, the zero product property tells me that when you have a product of two things, one of those two factors must be 0. So therefore, I have two possibilities. Either the first factor, x minus 7, is equal to 0, or the second factor, x plus 2, is equal to 0. So what's happened is I took this equation, this quadratic equation, which I didn't know how to solve, and I factored it into two linear equations, which I do know how to solve. And then using this zero product property, I was able to get this relationship for the linear equations, which I can solve. So if the first value is 0, x will be 7, or if the second value is 0, x will be negative 2. So to sum up all of the work we've done here, we just represent all the possible values of x using these set brackets, and we write the value 7 and negative 2, which is what's called my solution set. Okay, and that's how we will express our answers for quadratic equations. We'll express them as a solution set, a set of numbers which solve this equation. If we go back and check this, like say I plug in 7 to this equation, you can check these answers and it will actually work. When x is equal to 7, the first case, I'd get, when I plug it into x squared minus 5x minus 14, I'd get 49, which is 7 squared, minus 35 minus 14 equals 0. Well, 49 minus 35 is 14, minus 14 is in fact 0. And if we did this for negative 2 as well, it would also hold up. So what it means to be part of the solution is that it satisfies the equation. Okay, let's look at another example. 2, x squared plus x equals 6. Well, here I have a problem because it's not equal to 0. So I can't use the zero product property, which I'm going to abbreviate ZPP for zero product property, on 6. So what I need to do is convert this to its standard form so that it's equal to 0, and I'm able to use that property. So I'm going to rewrite this equation. X squared plus x, and I'm going to subtract 6 from both sides, so I'll get minus 6 is equal to 0. Now that it's equal to 0, I can use the zero product property. So I'll factor the left-hand side. What multiplies the negative 6 and adds to 3 would be x plus 3, x minus 2. Okay, so the zero product property tells me that one of these two factors must be 0. Therefore, x plus 3 equals 0, which occurs when x is negative 3, or x minus 2 is equal to 0, which occurs when x is equal to 2. Therefore, my solution set in this case is the values negative 3 and 2. So in general, when you're solving a quadratic equation, here are some of the key steps that you'll want to take into account. You'll first need it in standard form, meaning it needs to be equal to 0. You'll then factor your equation so that you can represent it as a product of two terms. Then you'll apply the zero product property, to get two linear equations, solve those linear equations, and represent your answer or your solution with set notation. Okay. So sometimes, however, you won't be given the equation and you'll have to make the equation yourself. In situations like this, we can use what we know about how math terms are spoken aloud to go from a written sentence into an equation that we can solve. Okay? So I'm going to read through this equation. It says the square of a number decreased by twice the number is 35. What is the number? Well, to help make sense of this equation, or make sense of this problem, I'm going to start by defining a variable. And I'm going to do that by letting the variable x equal the number, exactly what we're looking for. I'm going to represent the word number by the pound sign. So I'm going to let x equal the number. So now I have a variable that I can use in my equation. Now I have to interpret that equation from this sentence. So it says the square of a number. Well, here's the number. I just represented it with the value x. So the square of that number would be x squared. Now that value is decreased by, well, to decrease something, I subtract twice the same number. So I'm subtracting twice the number, which again I represented by the variable x. And when I do that operation, the result is 35. Now, is a key word in math for equals. It's equivalent to 35. So now I've created an equation based on this sentence. So all I have to do is follow the steps from the previous two examples. I need to get it in standard form by subtracting the 35 from both sides. Then I'll need to factor my equation. So the value that will multiply to negative 35 and add to 2 will be negative 7 and positive 5. Then I'll apply the zero product property to say that x minus 7 would equal 0, which occurs when x is 7, or x plus 5 equals 0, which occurs when x is negative 5. Therefore, my solution to this equation is negative 5 or 7. So the number x could be either negative 5 or 7. Those are the two numbers that will satisfy this result. So there's a couple of key things to keep track of when you're doing a word problem. First, notice that I started with a let statement. I established a variable by letting x equal the thing I'm looking for. You will always need to include a definition of your variable in your solution. You then need to interpret the question and write an equation to represent the given information. That was the second thing we did. We broke down what this question said into an equation. And then I solved it by the method that we've just discussed for solving quadratic equations. Okay. In this one, It says the sum of the squares of two consecutive negative integers is 61. Find the integers. Notice that this is plural, meaning I'm going to have to find two values. So I'm going to start by establishing a variable. I'm going to let x be the first. Actually, I was going to say integer, but it's in fact a negative integer. Negative integer, which I'll abbreviate in this way. Well, then do I need a new variable to represent the second? In this case, no. And it comes from what it means to be consecutive integers. Examples of consecutive integers are things like 5 and 6, or 11 and 12, or -5 and -4. Two integers which are directly after each other. Well, if x is the first, then x plus 1 would be the next, or the second, negative integer. So sometimes creating your variables from the equation can be a little bit tricky, but if you think about what it actually says and break it down, it's not too bad. So now that I have my let statement and I know what my two integers are represented as, I have to interpret the question. So it says the sum, meaning I'm going to be adding something, of the squares of the two consecutive negative integers. So I'm adding up the squares of these two values. That would be the first integer squared plus the second integer, which is x plus 1, all squared. And that expression is 61. So this will equal 61. Okay, so I'm going to try to get this equation in standard form by expanding this value. Now, since it's a square, I can use the perfect square pattern, and I know it'll expand to this. Then I'm going to combine like terms and bring my 61 over. So the x squared plus x squared would be 2x squared plus 2x, and when I subtract 61 from both sides, I'll end up with minus 60 equals 0. Now it's in standard form. Now I'm going to write a tip that can be helpful to you. So here's a tip. So now I'm going to go ahead and factor. Well, notice there's a greatest common factor of 2, so I'll pull that out. I have 2x squared plus x minus 30 equals 0. Then I'll factor what remains, because it can factor again, and I'll get x plus 6 times x minus 5. And I'll apply the zero product property. Now notice that in this case I have 3 factors. But because this is a constant number 2, and 2 doesn't equal 0, that value by itself will never be 0. Therefore, one of these 2 remaining factors must be 0. So I get that either x is negative 6 or that x is positive 5. Now here's where you have to do some interpreting. Remember what the value for x was. X is a negative integer. Well, positive 5 is not a negative integer, so that does not satisfy what this original question asked for. So when that happens, we reject solutions which do not meet what the question is calling for, how we defined our variables in the very beginning. Therefore, x is negative 6. So the first integer is negative 6, which makes the second integer, which is x plus 1, negative 6 plus 1, which would be negative 5. Okay? We can also arrive with quadratic equations in some geometric circumstances. So here it says the length of a rectangle is 4 centimeters less than twice its width. If its area is 70 square centimeters, find the dimensions of this rectangle. Well, just like before, I'm going to start with a let statement, but because this case it's talking about an object, the rectangle, I'm also going to draw a picture of the rectangle. So I'm going to let W equal the width of the rectangle. So that's my definition. So I'm going to find the width first. Well then, let's represent the length. The length, which you can use as an L, is 4 centimeters less than twice the width. So I need twice the width and then 4 centimeters less than that. Well, we've already represented the width by W, so the length will equal twice the width and then 4 less, so I'll have to subtract off 4. And I get this. Well, it says the area of this rectangle is 70 square centimeters. So you have to recognize that the area of a rectangle is the length times the width. So in this case, the area, which is 70, would equal the length, which we have already determined to be 2 times the width minus 4, times the width. So 70 is equal to 2w squared minus 4w. And when I rewrite this equation in standard form, I end up with 2w squared minus 4w minus 70 would be equal to 0. Now here's the first of 2 tips that I'm going to give you in this example. Remember that equations are symmetric. We had a symmetric property of equality. So rather than writing the 0 on the left-hand side, I'm going to erase it and rewrite it on the right-hand side. Because equations are symmetric, and I don't have to write the 0 on the left, I can write it on either side, it makes no difference. So that got it in standard form for me. Now, the second tip I'm going to give you is that if there's a common factor of all of the values, you can divide the entire equation by that value. If I divide both sides by 2, it's going to make my equation easier. And you'll see why in a moment. But I'm going to write down that tip. So these are tips. If a common factor exists, divide by it to reduce. Divide to reduce. Now notice what happens. If I divide everything on the left-hand side by 2, I'd end up with w squared, because I'm dividing by 2. 4 divided by 2 would give me 2, and 70 divided by 2 would give me 35. Would equal 0 divided by 2 is still 0. So what I've done is just made this slightly more complicated quadratic equation easier to work with. So now I'll factor, and I get w minus 7 times w plus 5 equals 0, which is exactly the same as a quadratic equation we ended up with in number 3. So I'll skip right to the solution set, which is it could either be 7 or negative 5. But uh-oh, I have a problem. Because w is representing the width, which is a distance measurement. It's a length. And distances, or lengths, cannot be equal to negative numbers. They can only be positive. So what's going to happen is I'll end up rejecting this negative length. That's not a possible answer. So I now know that the value for w is 7. So the width is 7, which makes the length of this rectangle 2 times 7, which is 14, minus 4, which is 10. So the dimensions of this rectangle are 7 by 10. Finally, the last question is if the area of the shaded region is 96 feet squared, then find the value of x. Now, this question is a little special because you do not need a let statement. And this, the only reason you don't need a let statement is they have already defined the value of x in this equation. So if you are ended up in a question where the variable is already defined, you don't have to create your own variable. But in order to properly interpret this question, what we really need to do is break down this diagram into things that we know how to calculate. Now, the thing that we just talked about was the area of rectangles. And it's easy to take this strange looking figure and turn it into a sequence of rectangles. So to do that, notice that if I draw a line here, I'll break up this figure into two rectangular shapes. So I'm going to go ahead and draw that line, and that line will go across, and because it's a rectangle, the opposite sides will be equal, so this portion will be x, and since the entire length was 3x, what would be left on the other side would be 2x, so that this x length plus this 2x length would give me the total 3x length. Once I've done that, I can calculate the areas of the two portions of this shaded area individually. So area is length times width, so the area of this section would be 2x, its length, times its width, which is x plus 6. And the area of this shaded section would be x times x, or x squared. So the total area of the shaded region would be equal to 2x times x plus 6, the first portion, plus x squared, the second portion. So I get that the area when I do my distribution and combine like terms would be 3x squared plus 12x. And that's by distributing this 2x and combining like terms. The final simplified result will be this. I know that the value of the area was given to me to be 96 square feet. So I can plug that into the area. I get 3x squared plus 12x. I'll bring the 96 over, and I'll get 3x squared plus 12x minus 96. Now, rather than writing, again, the 0 on this side, I can use the symmetric property to write it on the other side. I notice that there's a common factor of 3, so I'm going to divide both sides by that common factor of 3, and I'll end up with x squared plus 4x minus 32 equals 0. And now that I have a quadratic equation in standard form, I can go ahead and solve it by factoring and applying the zero product property. I'll end up with x minus 4 times x plus 8, which gives me two possible values. Either x is equal to 4 or x is equal to negative 8. Now, just like in the previous example, I have a small problem with negative numbers because x represents a distance, and distances cannot be negative. So I'm going to reject this value because it's a negative distance. Therefore, I get only one value for x, and it is 4.